Okay, so from the review, any you would like to see done? We had some good teaching going on there. Good to go? Okay. Katrina, we're okay? Good. All right, so then I'm going to jump on into, we're going to talk about domain and range. So this is section 2.2 in our book. So we know that our definition, so the domain, we know is the set of all input values, is the set of all input values. And we know the range is the set of all output values. So the range is the set of all output values. So they're sets, not that that's a huge deal for us, but they should use set notation. That's not something I would mark a problem right or wrong for. Sometimes we will artificially restrict the domain based on the context of the problem. Sometimes we choose to restrict the domain. For example, if we were talking about something like our functionless area is pi r squared, we might say, even though this function would be defined for any choice of r, you could put any real number at all, in the context of a problem that this is the area of some circle, it's pretty hard to have a radius rather, that's negative, or you might even argue that it really wouldn't make much of a circle if the radius was 0. So we might choose to artificially say, because of the context of this problem, we're going to restrict the domain and say that r is greater than 0. Okay, but if it's not specified, so if the domain is not specified, so it's not given to you, we assume it is as large as possible. So where possible, we would like it to be all real numbers. But we're going to see there's 3 different kinds of functions that will have restricted domains just because some values of x aren't going to make sense, aren't going to be defined in the function. And so we have to be aware of that and understand what that domain restriction is going to be. Well, also then, once we kind of know what the domain is, then we're going to try to figure out what the range is. Range in general is am I erasing that too fast? Range in general is a much tougher question to answer. And so we will talk about it in here, usually, unless I give you something graphically. Usually I'm gonna, if I just give you an equation and ask you for domain and range, I will let you use your calculator to find the range. But I'm gonna start in this class talking about how you would figure out what that range is without using your calculator, because by the time we get to next year in AP Calculus, you're going to need to have that kind of skill, that kind of deeper understanding that you can tell what the range is without using a calculator. But before we get to the hard stuff with the equations, let's look at some graphs. So let's find domain and range from these graphs. Find the domain and range of the following. So I'm going to give you not an equation yet of a function, but rather I'm going to give you this graph. So here's our axis. We're going to go to -2 on the x and to +3 on the y. And we'll 4 on the positive y, and down to negative 1 on the x, negative y. And so we're going to say that at this point, it looks like negative 2, positive 1 is going to be an open circle. It's going to come down to that point 0, negative 1, and it's going to end in a solid dot up here. So this is our function. So we can see a graph of that function. And so from the graph, we want to be able to say, what is its domain and what is its range? Can you identify what the domain and range are? So I'll give you a moment to look at that, scratch your head, think, turn to your neighbor, tell them what you think the domain should be, and they can answer back what they think the range should be, and then we can, in a nonviolent manner, resolve any disagreements that we have. Use your voices in this part of the class.
Greater than negative 2 and then less than or equal to 3 and y. Greater than or equal to 5 and less than or equal to 3.
Did you use interval notation? Or inequalities?
Inequalities.
Okay, either one's okay. So on the first one, Aaron, what did you get for the domain?
Negative 2 for 2, and then greater than, or less than.
Less than, strictly less than.
Not, but not equal to x,
Good.
and then less than or equal to 3.
Good. So we're not including the negative 2 because of the open circle. We are including the positive 3 because of the solid dot. And we have all the values of x in between there. Does anybody use different notation? This is called inequality notation. Does anybody use the interval notation? Okay, so, and then what did you get, Paige? How did you write yours?
I got curly bracket, negative 2.
Parentheses, good. Negative 2, good.
And then 3 bracket.
Good, excellent. So not including the negative 2, we show with the parentheses, and including the 3, we make it a bracket. And you got to go small to big, so smaller number to big number. Okay, range. Katrina, what did you get for range?
In brackets, negative 1, 4.
Good. So including the negative 1, including the 4. Anybody do it in inequality notation? Go ahead, Cade.
Negative 1 is less than or equal to y, which is less than or equal to 4.
Excellent. So those are equally acceptable. Okay, so let's do different graph. So here we're going to have a vertical asymptote at x equals positive 1 and a horizontal asymptote at y equals 0. And our graph is going to look something like this. And we're still looking for domain and range. And you can discuss again.
Is that at 1? Sorry, the verb.
Yeah, this is at x equals 1.
Okay.
So that's going to be colon.
I wonder why.
What are you thinking?
Picture day. Nice. Is it after? I thought it was before lunch. Is it after lunch? Huh?
I don't think it's not picture.
Isn't it? Or is it next week? I think it's
I think it's next week. Yeah.
Well, shoot. Oh, well. I would have dressed nice anyways. Whatever.
All right. Well, let's do this one a little quicker. What's our domain going to be? Anybody we haven't heard from?
Negative infinity to infinity.
Negative infinity to infinity. So is every single value of x used?
No.
No. Which one are we not using?
X can't be 1.
Yeah, so we don't have 0 in this one. So x, there's no point on the graph that has an x coordinate 0. So our domain doesn't include 0. So instead of this, Now, it might be easier, I think, to do in this case using inequalities. How would you say everything except for 0?
X doesn't equal 0.
And actually, it's not 0.
Oh,
It's
it's 1.
1,
X
yeah.
doesn't equal 0.
So yeah, you can just, I think this is the cleanest, easiest way to do it. If you were going to do interval notation, you're going to have to do 2 separate intervals, which is fine.
Can you
So,
do last
Negative
year?
infinity to,
This was like an extra step of last year, Ms. Batista had us, right? Like, X is an element of all real numbers, X cubed.
and that's
is
fine.
1.
And that's, yeah, and that's called set builder notation. And you're fine with that? It's, and we used to do that all the time. It used to be when I was in college, that was a couple of years ago. A friend of mine used to say, every math book starts the same because every math book, chapter 1 would be on sets. And so there was really a big deal, and you would say stuff like X such that X is an element of the reals and X is not equal to 1, and that was the real formal language and notation of math, and every math book would start with something so they would clarify that this is how you're going to write it, and that's kind of in the last few years, it's just not done very much anymore. Now, I'm thrilled if I can get you to write braces. If you write braces, and that like warms my heart, but I'm not going to mark it wrong if you don't, because it's just not that, that's not the point of the problem.
So for like the domain, we don't have to include the values that are included, just the ones that's not included.
Well, so what this says, so what this is saying is that anything that isn't 1 is included in there. And so that's how we're including all of that stuff there. Now you could also do it like in interval notation. You'll go -1 to 1, not including the 1, but then you also have to say either a comma or, and I know Ms. Batista taught this, it would be the formal symbolism is that's a union symbol, and that would go from 1 to infinity. And again, that is not used very much anymore, kind of giving away your age when you use that. So you could do that, or you can write the word or. Okay, so that's another way of saying that same thing. So that's just notation and symbolism. How about range? What y value?
0.
Everything except for 0 here because of that horizontal asymptote. And again, I think the easiest way is going to be just to say y not equal to 0. Okay, we have a more interesting one, I think. So let's get to that. And then I want to do some range and some harder ones still here. There's some harder domain issues that are going to come up. So let's go from -1 to 3, 1, 2, 3, and we'll go from -2 to +1. So there's our axes, I guess, plural. And so we're going to go with an open circle, horizontal line, solid dot. 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 Sometimes looks like sometimes called a step function, because it kind of looks like a staircase, you know, where you're kind of walking up or down stairs there. So it is a function, right? Because a vertical line is only going to intersect the graph in one point. It's going to not hit anything with that open circle, but it will intersect at that solid dot. Now the tricky part is, can you figure out domain and range? So how about domain? From where to where?
Parentheses, oh, sorry,
Go ahead.
From, like, parentheses,
Okay, I'm gonna go with this.
-1
-1.
to bracket 30.
Okay. So not including -1 because of the open circle. But we covered up that 0 there because of the solid dot. We get everything along here. We do include the 1, everything. We include the 2 all the way to 3, including the 3. Or we could say from -1 less than x less than or equal to 3, either of those notations. The range is the interesting part. I mean, the domain you had to think a little bit. The range is one that throws a lot of people. So what are the page? Give it a shot.
Isn't that y equals -2, y equals -1, y equals 0, and y
Excellent, excellent. So it's not the whole interval. We don't get all these y values in between here because there are no y values that are used between -2 and -1. And so you can just list the different finite number of y values that are used. All of these have y value -2, then the next y value is -1, and 0 and 1. So we just list those. And you can use the y equals and the formal notation, but I'm happy just with if you list those values. But it's not an inequality, not an interval, because there's not all those points in between. Okay? So we want to move then from the graph to an equation. Can I erase that? Good to go. So there are three kinds of functions. There are three types of functions which have restricted domains. So these I'm talking about now equations. So we're going to look at a function given as an equation or a formula. So there's three different types that have restricted domains, and this is something you just have to be on the lookout for and be aware of. So by their structure, they're not going to be able to accommodate all real numbers. So we're going to do some examples. I'm going to first do just the domain, and then we're going to come back to this and use our graphing calculators and try to find the range, which is a harder question. So let's look at f of x equals 1 over x minus 3. G of x is equal to the square root of x plus 3, and h of x is equal to the logarithm of, let's say, x minus 4. So the three kinds of functions that have restricted domains are anything that's got a variable in the denominator, something where the denominator could be 0, because that's going to be a problem, because dividing by 0 is not defined. Any even index radical that's got a variable in it. So square root, fourth root, sixth root, they have a problem with negatives. So what's inside this radical has to be greater than or equal to 0. It can be 0 because square root of 0 is defined. It cannot be negative because these are real valued functions. So even though you may have seen and heard of these imaginary numbers, I don't know what you're talking about in here. We talk about functions, that's not going to exist. So you can only put in real numbers, you can only get out real numbers. And a logarithm is not defined for a negative or 0. So whatever is in the logarithm must be strictly greater than 0. Okay, so the domains, what we do here is we just say, what is it that x cannot be? So you kind of start with setting the denominator equal to 0, only you don't want it to be 0. And then you just solve that. So as long as x is not 3, this will be defined. So its domain is everything except for 3. Make sense? Now, the second one, the issue is with the negatives. 0 is okay, positives are okay. So we take what is inside the radical and we say that has to be greater than or equal to 0. And then we solve that. So if we subtract that 3 to the other side, as long as x is greater than or equal to -3, the x plus 3 that is in that radical will give us a positive or 0 number, and a square root or fourth root or sixth root of a positive or 0 is defined, and so that becomes our domain. And anything that's not in there is going to give us a negative, and a square root of a negative is not defined. It is not a real number. Very similarly, a logarithm does the same thing, except it can't equal 0, so we can't have it equal to 0. So we are going to take whatever is in that, it's called the argument of the logarithm, whatever is going in as an input to that logarithm, and make it strictly greater than 0. And when we solve that, that is going to become our domain. Okay, now, finding the range is going to be a little trickier. And so we can do this with a calculator, but I think I'm going to, I may come back to that. I want to talk about some tricky domains, or you can, what do you think? Let's do maybe, let's do this one on our calculator so that we can see what that's going to look like. Because even though you can use your calculator, you're going to have to use a little interpretation. Sometimes it's not going to show up as clean and as clear as you may hope or like. So I'm going to turn on my calculator here, and hopefully my TV will respond. Now, the people watching the video are going to display